Let's take multiplying same bases to the next level. So as we learned, anytime you have same bases and you're multiplying them, you just add your exponents together. So what happens when you have coefficients in front of your bases? So for example, if I had a 4 here and a 2 here. So if I had 4a to the n power times 2a to the n power, what I'm going to do is I'm going to multiply the 4 times the 2, and I'm going to multiply the a to the m times the a to the n. In other words, I'm going to use my commutative property of multiplication, which allows me to multiply things in whatever order I want to multiply them in, as long as I have all multiplication. So 4 times 2 is 8. And then we have a to the m plus n. So let's apply this idea to some examples. In this first example, I can rewrite negative 2x cubed times 3x so that I'm multiplying my coefficients together, negative 2 times 3, and then multiplying same bases together, x cubed times x. And that just kind of helps me to be very clear what happens with my coefficients. My coefficients, negative 2 and 3, just get multiplied together. So what's negative 2 times 3? Negative 6. And then I have 3 x's. So remember, this means x times x times x, 3 x's, times 1 more x. So how many x's is that altogether? X to the 4th. And the shortcut to understanding that x to the 3rd times x to the 1st equals x to the 4th is adding your exponents and keeping your base. So I'd like you to pause the video and try the next two problems and then come back and check them. So for the next problem, you should have multiplied negative 6 times negative 5 and y to the 4th times y to the 3rd, which will give you 30 y to the 7th. In the next problem, we have 8 times negative 4 and m to the 5th times m to the 3rd. So we're multiplying all that together. However, what we really end up doing is multiplying 8 times negative 4 to get negative 32. And we multiply m to the 5th times m to the 3rd, where you keep your base, add your exponents to get 8. And we end up with negative 32 times m to the 8th. So